Okay, I hope I'm audible to all my students who are attending this particular lecture for the Introductory Mathematical Methods for Economics course. In this particular lecture, I intend to start with the discussion of the 2023 question paper which has come up at University of Delhi for the Introductory Mathematical Methods for Economics for all those students who are pursuing BA Honors Economics from University of Delhi. So all students can see the question paper on your screen. So in this particular lecture, I'm going to start with the discussion of problems from section A, which has come up in this particular paper. So let's quickly start with this particular lecture. So let's look at the problems from section A. So this is question number 1, which all students can see on your screen. Okay, let's look at part A. For the following function f of x, which is ln 4 minus x square, part 1 asks us to find the domain. Part 2 asks us to find the asymptotes for this particular function. So let's quickly come to the whiteboard and let's solve this. Remember, students are going to find this in my lectures on relations and functions and coordinate geometry, which I have covered up in my introductory mathematical methods for economics course. Okay, so if I come to the whiteboard, I'm just writing the main heading for completeness. We are looking at Delhi University 2023 question paper for the introductory mathematical methods for economics course. I also call it as the MME-1 course. And this is for all those students pursuing economics honors from University of Delhi. So let's look at question 1. Let's look at part A. I'm quickly writing the piece of information given to us. We are given the function. We are given that f of x is equal to ln of 4 minus x squared. First part asks us to find the domain. Now remember from my lectures on relations and functions, when is for a natural logarithmic function, when is this function well defined? So I can say that f of x is well defined only if 4 minus x square is greater than, strictly greater than 0. Remember, all students can recall this from my lectures. So I can write here recall from my lectures on functions, recall from my lectures on functions that y equal to ln x is well defined, where ln denotes natural logarithm. Y equal to ln x is well defined only when x is strictly greater than 0, where ln denotes the natural logarithm. Ln denotes the natural logarithm. Okay, so y equal to ln x is well defined only when x is strictly greater than 0. So ln of 4 minus x square will be well defined only when 4 minus x square is strictly greater than 0. This implies x square is less than 4. And remember from my lectures on inequalities, absolute values and inequalities, x square less than or equal to 4 implies x lies between minus 2 and plus 2. Remember, x square less than a square implies x lies between minus a and plus a. So x square less than 4. 4 I can write as 2 square. 4 I can write as 2 square. So x square less than 2 square means x lies between minus 2 and plus 2. So this is the domain of this function. So I can write the domain of the function is minus 2 to 2, where minus 2 and 2 are not included. Okay, then let's look at asymptotes. So we are given that y is equal to f of x is equal to ln of 4 minus x square. Okay, now there are 3 asymptotes I have covered up in my lectures. One is called the horizontal asymptote, then we have the vertical asymptote, and then we have the oblique asymptote. Okay, now if you look at this particular function, you can clearly see that this particular function has no horizontal and no oblique asymptote, because even if you plot a graph of this particular function, I can say that the above function, has no horizontal asymptote. Remember from my lectures on coordinate geometry, what is a horizontal asymptote? A horizontal asymptote is basically a straight line such that the curve tends towards the line as x or y tend to plus or minus infinity. When I look at horizontal asymptote, it's a straight horizontal line such that my function f of x tends towards that line as x or y tend to plus or minus infinity. In this particular case, the function has no horizontal asymptote and no oblique asymptote as well. When is this function not defined? You can clearly see that this function is not defined when 4 minus x square is equal to 0. So recall that ln 0 is minus infinity. So I can say that when will ln be 0? When will this be 0? So I can write, therefore my vertical asymptote is given by 4 minus x square exactly equal to 0. Because when 4 minus x square is equal to 0, I have ln 0, which is minus infinity. So 4 is equal to x square. So this implies x is plus minus 2. So this is my vertical asymptote. So I can say that my function f of x tends towards the line x equal to plus minus 2. It tends towards the line x equal to plus minus 2. So that is my vertical asymptote. You can clearly see x equal to plus 2 and x equal to minus 2 is a straight line. It's a straight vertical line. Okay, so hoping all students attending this lecture have understood this. Okay, so I'm again repeating it. There are no horizontal asymptotes for this particular function. And remember from my lectures, how do we work out the asymptotes? Suppose I have to find the horizontal asymptote. Look for the highest power of x in the equation, that's x square. Does it involve y? No. So there is no horizontal asymptote. There is no oblique asymptote also. You cannot divide. Oblique asymptotes are going to exist only in case of rational functions of the form when you have a polynomial divided by another polynomial. Those have oblique asymptotes. This particular function only has a vertical asymptote. So how do we find the vertical asymptote? We want the function to be not defined. So at that particular line, this particular function y equal to ln 4 minus x square is not defined when 4 minus x square is equal to 0. Because ln 0 is minus infinity. Okay, so 4 minus x square equal to 0. When I solve this, I get x as, when I solve for 4 minus x square equal to 0, I get x as plus minus 2. So x equal to plus 2 and x equal to minus 2 are two vertical asymptotes. So I can write, therefore x equal to 2 and x equal to minus 2 are the two vertical asymptotes. That means my function f of x will tend towards them, but not cut them. My function f of x will tend towards x equal to plus 2 and x equal to minus 2, but it will never intersect these two lines, x equal to plus 2 and x equal to minus 2. So hoping all students have understood this. Moving to the next question. If I scroll down the question paper, let's look at question 1 part B. We are given that g of 2 is minus 4. We are given that g dash x is square root of x square plus 5. Okay, so we need to find out using the linear approximation, we need to estimate g of 2.05. Now I have covered these concepts in my lectures on single variable differentiation, concepts of linear approximation. So if I quickly come to the whiteboard to solve this, erasing all this off. Okay, so if I have to do the linear approximation in general, so in general, I can write that g of x is approximately equal to g of a plus g dash a times x minus b. Check out my lectures on single variable differentiation. Okay, so now what is given to us in the question? If students can recall that in the question we are given that g, so in the question we are given g of 2 is minus 4 and g dash x is square root of x square plus 5. So what will g of x be? It will approximately be equal to g of 2 plus g dash 2 times x minus 2. Now g of 2 is minus 4. What will g dash 2 be? G dash x is square root of x square plus 5. So g dash 2 will be square root of 2 square plus 5, which is square root of 4 plus 5, which is square root of 9, which is 3. So my g of x will approximately be equal to g of 2 is minus 4, g dash 2 is 3 times x minus 2, which implies g of x will be approximately minus 4 plus 3x minus 6. So g of x will be approximately 3x minus 10. Now what do I need to find? I need to find the value, the approximate value of g of 2.05. So therefore, g of x is approximately 3x minus 10. So g of 2.05 will approximately be 3 times 2.05 minus 10, which comes out as negative 3.85. This is the answer for question 1 part, negative 3.85. So hoping all students attending this lecture have understood how we have solved this particular problem. Okay, so if I come back to the question paper, so we have done question 1 completely. Okay, now in the next lecture, I am going to solve question number 2 from this particular question. So I stop in this lecture. I hope students have enjoyed this lecture. Any doubts, you can unmute your mic and ask, or you can get in touch with me for doubts on call or WhatsApp, or you can mail me your doubts at divineschoolof economics@gmail.com. This is where I stop in this lecture.